Hello and welcome back everyone to Aviatrix Deep Dive with Saad. Today I'm going to start a new topic which is a common use case for enterprises, and at the same time it's one of the main security solutions. It's called Aviatrix Firewall Network, or in short Aviatrix FireNet. So this is a prerequisite session for all the upcoming CSP specific firewall sessions which I'm going to do. For example, FireNet in AWS, FireNet in Azure, FireNet in GCP, and FireNet in OCI. So what is FireNet? FireNet is the mechanism to do the policy-based service insertion of next generation firewalls. Most of the times this is the next generation firewall service insertion. At the same time, we do the service insertion of Aviatrix fully qualified domain names gateways as well. And there are scenarios where you wanted to service insert the third-party load balancers also. So why you need FireNet? You need FireNet because it's very complex to service insert the next generation firewalls using the native constructs. It's either all or nothing. This complexity I'm going to discuss in a few moments, but overall just understand, if you need to insert the next generation firewalls, then your traffic from your application VPCs, VNets, VCNs, or in short, I'm going to call it application spokes or just spokes, is either all traffic is going to go to your firewalls or no traffic is going to hit the firewall for any kind of service inspection. Basically, you need FireNet for security. You want it to provide the compliance and audit capability as well. And at the same time, the common repeatable service insertion within a region, across the regions and across the clouds too. There are times when multiple business units in an enterprise, they don't agree on a certain firewall rule. At that point, what are you going to do? What are your options? With Aviatrix FireNet, what you can do, you can create parallel environment, parallel architecture with different firewall networks, and every department can control or have a complete control on their security firewalls rules too. You need FireNet when you wanted to have a zero-touch firewall deployment with the bootstrap support too. For big enterprises, 2 firewalls may not be good enough. You might need tens of firewalls. Aviatrix FireNet provides you the 20 firewalls capability in a single transit VPC, VCN, or VNet. The active nature of the firewall is also an important use case for FireNet. For the native constructs, most of the time you can utilize the firewall but in the active standby manner, which basically means you are going to utilize your firewall licenses and the compute without using them because those firewall is going to be in the standby. Service insertion of the next generation firewalls using the native constructs require either the IPsec or a GRE. In either way, you are going to take the performance hit. And in order for you to exchange the routes, you have to enable the BGP, which means you are going to manage not only the tunneling protocol, but at the same time some dynamic routing protocol, which is BGP in your case. And there are times when you have to enable the source NAT on the firewall, which basically means you are going to lose the visibility of the source IP of your applications. For a legacy application that requires you to enable the 2 tuples hashing algorithm, that could be another important use case to have the Aviatrix FireNet. Basically, without the FireNet, it becomes the customer responsibility to take care of all the configuration, routing, and the traffic redirection without any troubleshooting tools and visibility. So let's discuss where you need the FireNet. Let me draw an architecture very quickly so you can follow along. I just drew a multi-cloud network architecture for a single cloud in a single region. It could be any cloud. On top, these are my application spokes, which could be VPC, VNet, or VCN. And then in the middle, it's Aviatrix Transit with the transit gateways and some firewalls. It could be any firewalls of your choice. Now, the question is where you need the FireNet. You need the FireNet when your application is spoke A wants to communicate with the application sitting in spoke B. At that point, the application traffic is going to go through the Aviatrix transit to the firewalls, comes back to the transit, gets to the application sitting in the spoke B. And then the return traffic is going to follow exactly the same path. So that becomes your inter-spoke traffic inspection. At the same time, it could be multiple regions, it could be multiple clouds. So the spoke A may wants to communicate with spoke Z, and this spoke could be entirely in a different region or a CSP. So now you can see applications sitting over here in A, and let me draw it with a different color. For example, this is the application, and application is communicating with another tier or different application across the region or across cloud. When they are communicating, they might need to get the inspection done as well. Now, there will be times when you wanted to have the traffic inspected within the subnets within your spoke. So this could be your application A, and this is your application B. This could be in subnet 1, and this could be in your subnet 2. At this time, you wanted to make sure that these applications can communicate with each other. Not only communicate with each other, but also when they communicate, the traffic must be inspected by the firewall sitting in the transit. So you wanted to send the traffic all the way over to the transit at this point. So this is called intra-spoke inspection. You also have some of the applications who wants to downloading the patches from the internet. At that point, you need to egress through these firewalls, and at the same time, you wanted to make sure whenever they egress through the firewall, the traffic must be inspected. So the traffic path, either the traffic path is this way, which is the egress direction, you wanted to make sure the traffic is inspected, whether the traffic is within a spoke or inter-spoke, multi-region or multi-cloud, or in the same region. For all those use cases, you want to enable the FireNet functionality. Ingress, on the other side, when the traffic is coming in, trying to access your application, at that point, the architectures are different, which requires a separate session, which I'll be doing it later on. One more thing which we have not discussed so far is the on-prem traffic too. So when on-prem applications communicating with the application in your cloud world, you want to make sure those traffic is also getting inspected by the same firewalls too. This is also why you need the FireNet. Okay, so how would you deploy this entire architecture? On top, you see all these spokes spread across multiple regions and multiple clouds. Most of the time, this is a brownfield environment. So Aviatrix controller is going to ingest your application spokes. At this point, all you have to do is to just deploy the Aviatrix spoke gateways, and that's pretty much it. On the other side, the transit is something that Aviatrix recommends, and that you let this transit VPC, VNet, or VCN deployed from the Aviatrix controller. Why? Because we have to take care of the routing tables, the subnet, associations of the subnets to the routing tables, and at the same time, for certain CSPs, we need to deploy the load balancer, which is the Intel load balancer in this transit VPC, VCN, or VNet 2. For those reasons, we wanted to make sure that the Aviatrix transit is managed and deployed from the Aviatrix controller, so you don't have to take care of all those. When you deploy Aviatrix Transit Gateway, it is a best practice to always deploy in the high performance encryption or insane mode, because you wanted to make sure that you are future proof. When you deploy the Aviatrix Transit Gateway, then you also need to make sure that you are enabling the transit FireNet functionality on that. You either can deploy the any next generation firewalls from the Aviatrix controller, or we can ingest. But since this is the transit VPC, VNet, or VCN that you are deploying from the Aviatrix controller, most of the time these next generation firewalls are deployed from the Aviatrix controller. So a couple of things which you need to make sure that you, before you deploy, that you do have a subscription within the CSP's marketplace. And then if you are managing these firewalls from any centralized firewall manager, then you wanted to make sure that you have completed the integration portion from the Aviatrix controller also. By just creating the network segments and placing the gateways in this network segment does not mean that the firewall policy is also enabled on them. So you have to create a firewall policy for these gateways. So let's say if I am going to place my spoke A into a FireNet policy. So for example, now these gateways have a FireNet policy. So what is going to happen? When A communicates with B, then traffic hits the transit gateway. Now transit gateway is intelligent enough that it knows anytime traffic is coming from spoke A, I'm going to redirect the traffic to one of these firewalls. Let's say there are only 2 firewalls in this particular transit before sending it over to the B. B receives it, B sends the return, and then the traffic comes to one of these transit gateways, goes back to the same firewall because the hashing is done by the Aviatrix transit gateways at this point, and then sends the traffic over to the same firewall. Firewall inspects the traffic, sends it back to the transit gateway. Transit gateway is going to send the traffic back over to the A. So what is going to happen when Z is communicating with A? At this point, even though Z spoke gateways are not in any kind of inspection policy, even at that point, traffic goes through its own transit, comes to this transit. Once the traffic gets here, it knows the destination of this traffic is A, which is in the FireNet policy. So before it sends it out to A, it is going to send the traffic over to one of these firewalls and keep the hash with it, and then sends the traffic to the A. So basically, it does not matter whether it is a source or the destination. Basically, all the transit gateways care whether the spoke gateways are under the FireNet policy or not. Once they are under the FireNet policy, so the direction of the traffic does not matter whether it's a source or destination. The transit gateway is also always going to redirect the traffic over to the firewalls. What is going to happen when you have a big enterprise which has hundreds and hundreds of these spokes in a region? At that point, you might have to break it down. You might need multiple of these architecture parallel. But you really don't want at this point to have the firewalls in every single transit, because that will be too many firewalls. So what are we going to do at this point? We are going to remove the firewalls from the transit, and then we are going to create another transit here, which we are going to call a multi-tier transit. It will have its own transit gateway, and at this time the firewalls are going to be deployed in a MTT or multi-tier transit. These transits are going to be paired like any other gateways. So let me actually clear this, and then it's going to be like this. Okay, so the traffic from Z, in order to get to the A, it's going to go through the firewalls and get to the A. The concept of the MTT, multi-tier transit, is discussed in a separate session as well. Let's talk about the performance of the FireNet. It all depends on the CSP, depends on the region where you are. The performance of the FireNet could go beyond 70 gigs of throughput. Now let's talk about some of the other FireNet features. So one of the features of the FireNet is egress through FireNet. What it means, basically for any time your application requires the internet access, and at that point you wanted to make sure the traffic which is destined for the internet first get inspected by the firewalls which are in the transit and then go to the internet. So what happens when you enable this feature on Aviatrix controller, which is called egress through FireNet, it is going to advertise a quad 0 route to all the spokes which are in the inspected list. For example, spoke A is in the inspected list because there's a FireNet policy over here. Then the quad 0 is going to be advertised to this particular spoke. If you are going to enable the FireNet policy on B, then B is also going to get a quad 0. So all the traffic that is destined for the internet, we are going to attract from the spoke to the spoke gateway, then the transit, and then the firewall to the. Another feature that Aviatrix FireNet provides is the exclusion list. There are times when you don't want certain type of traffic, certain type of prefixes to be inspected by the next generation firewalls. For example, Aviatrix controller traffic. It's unnecessary to inspect that traffic, and at the same time there is a scanner traffic which you don't want it to inspect unnecessarily because that's a lot of traffic and you don't want it to burn the resources of your firewalls. So at that time, what you need to do, you need to go back into the Aviatrix controller, enable this functionality, which is, we call it the exclusion list, and it works only for the east-west traffic. So for example, in A, there are certain prefixes you don't want it to be inspected. Then you just create a list of that. And a maximum of 50 comma separated prefixes are supported under this particular feature. Now, one thing which you need to remember that if you have enabled egress through FireNet, at that point, it does not matter whether you have any exclusion list or not. All the traffic, even though that prefix is part of the exclusion list, that will also be inspected by the Aviatrix FireNet. Another feature is the firewall management access. Now you can see these are the firewalls which are in the transit, and there are times when you wanted to manage these firewalls from its centralized management software, which could be sitting in the on-prem world or could be in one of those VPCs. You also have a requirement that you want to manage these firewalls on their private IPs. When you enable this functionality, which is called firewall management access, then what Aviatrix controller is going to do is going to advertise the subnet of the firewalls to the spoke or the on-prem, wherever the management software is, whatever you require, so you can access these firewalls using their private IPs. One question typically customer asks, like, how would I make sure that my FireNet is working fine? It could be I'm not passing the traffic. It could be because of the firewall rules. It could be because the transit may not be redirecting the traffic over to the firewall. How would I find out? So there is a function or feature on the Aviatrix controller, and it's called the traffic inspection. So it has two toggles, either enable and disable. When you disable the traffic inspection, basically Aviatrix transit gateways or FireNet gateways are going to loop back the traffic and sends it back wherever it is destined to. So that way you will figure it out that the traffic is reaching. And now if the traffic was not making it through the B, it could be because of the firewall rules, which needs a little bit of tweaking, or maybe there is something else which is happening on your firewall, so you can look inside the firewall. So this is a great verification feature which is available on the Aviatrix controller. So that's all I have for this session. In the next session, I'll be discussing about the FireNet in AWS.